Welcome to Train Signal. You're watching Monitoring and Troubleshooting Storage. So the first thing you look at if you're going to troubleshoot storage are wonderful log files. Everybody loves log files, right? Well, sometimes you actually have to go look at them. It's kind of like manuals. Sometimes you just give in, you just go do it. Actually, a lot of times when we're fighting storage issues, VM kernel and VMK warning are the place to go, because when a vSphere host is having issues, that's where it's going to write them. You're going to see things like device timeouts, latency issues, SCSI resets, all sorts of stuff. So whenever somebody calls me and says, hey, we've got a problem, storage, LUN keeps disconnecting, first thing I ask them to do, send me a copy of the VM kernel and VMK warning logs off of those servers, and let me take a look at them first. You've also got the storage RM log for SIOC, storage IO control, and the VOBD log for the VM kernel observations. But 9 times out of 10, I'm pulling VM kernel and I'm pulling VMK warning. VMFS5 file system. So this was introduced with vSphere 5, and in the blueprint it wants you to be able to name the differences. So trying to figure out, every time I see something in a blueprint, I just got to the point I'm like, how are they going to quiz me on that? I don't know. The only thing I can think of is maybe they'll say create a file system that supports this, and it's probably going to be something in VMFS5 that 3 couldn't do. So let's talk about it. Biggest change for me, well, I won't say the biggest, but one of the best changes for me is up to 64 terabyte in size. With VMFS3, the largest we could do was 2 terabyte. Unfortunately, that is the volume size, not what you can do with VMDK. VMDKs are still approximately 2 terabyte. That's something I wish they'd fix and hope they will soon. But for 5 and even 5.1, we're doing 64 terabyte VMFS volumes, but still 2 terabyte VMDKs. This is another big one. Not big for everybody, but it just gets rid of having a discussion about it. Sometimes I'm happy when choices get limited just so we don't all have to talk about it anymore, but this is one of them. It used to be when you were formatting VMFS3 volume, you would have to choose the block size, and the block size dictated the largest VMDK file, or really the largest single file that you could create. And it was 1248, I believe was what it was. And now everything is 1. No matter if you want to create a 100 meg file or a 2 terabyte file, you can do 1 meg block size. So when you format a volume VMFS5, you no longer have to answer that question. It also uses GPT, GUID partition table, instead of the old MBR, master boot record, which is handy, and everybody's kind of going that way for larger volumes. And you can now also do RDMs up to 60 terabytes. So if you've got a server and you need a 30 terabyte single volume, you can now do that with an RDM. But again, you still can't do a single VMDK above 2 terabytes. And it also supports very small files. It actually stores these in metadata areas, so it doesn't take a lot of space. I don't know anybody who stores a bunch of less than 1K files on top of VMFS, but if you want to, it's much more efficient, so go right ahead. Subblock size is also now 8K instead of 64K, so if you do smaller files, you're not chewing up as much space due to overhead. VMDKs, as I just said, are still limited. It's 2 terabytes minus 512 bytes, so right at 2 terabyte, or approximately 2 terabyte, as I always say, so just slightly under that. Most of the benefits, you get them if you upgrade a VMFS3 to 5. So it's a painless, non-disruptive process to move a VMFS3 volume to VMFS5. You get the sub-block sizes, you get the small file support, you get a lot of stuff. What you don't get when you do a migration or an upgrade is you do not get the block size. So if you have an 8 meg formatted VMFS3 volume formatted with 8 meg block size, when you convert it to VMFS5, it does not restripe the blocks to 1 meg. Is that a problem? Well, it can be a problem if you like to use VAAI acceleration for the array offload. And there's some things that cannot be done via VAAI if you don't change a block size. So if we want to do a storage vMotion from an upgraded VMFS5 data store with an 8 meg block size to a newly created one with a 1 meg block size, we can't use VAAI for that storage vMotion. It'll revert back to software because the block is different. So if you do that a lot, or maybe you're thinking, well, I don't do a lot of storage vMotions, but what about, say, storage DRS, where it would move VMDKs between data stores depending on load or capacity? In those cases, you probably do want VAAI support. So consider trying to evacuate all the VMs off the data store, reformat it with VMFS5 1 meg, and then move everything back. I know it's not a fun process, I know, and it's not a requirement, but just keep in mind it is an option if you want to use it. PSA and multipathing, we talked about these in depth, but here's a couple things to keep in mind. ESX CLI storage core path list to show known device and paths, ESX CLI storage NMP PSP to show the path selection policies, and if you want to see the storage array type plugins that are available, it's ESX CLI storage NMP SATP. Check for masked LUNs and claim roles. If you get a question like, hey, Bob called and said one of the vSphere hosts can't see this LUN, I would check claim rules, especially anything being claimed by the masking, the path mask or mask path, whichever one it was, claim rule, and check for that. So keep that in mind. VM kernel storage module troubleshooting. I don't know why this is in the blueprint. This is one of those that has me scratching my head because I find it hard to believe they're going to quiz you on this, but I've been wrong before, and you know, a lot of people assume I'll be wrong again, so why not? But it's not something you normally need to do. So there's a ton of advanced options. The thing is, this really has to do with kernel modules within the server. And every kernel module is different. There's just a ton, well, I'll take that back. Some modules have no options to set. Some have a bunch. So I guess I could see them saying, hey, you need to set this option on this module to 32 or whatever, and ask you to go do it. Here's an KB article on it. I'm not going to say go read this, but it's worth looking through. But the way that you do this is you can list the modules, and this is all done via the ESX CLI system module tree in the CLI. So to list the modules, you do module list. If you want to load a module, you do module load. I've never manually loaded a module. I've never manually set any of this stuff, to be honest with you. But if you want to set a parameter, it's module set. And if you want to list the settable parameters, it is module parameters list -m in the module name. So let's go take a look. All right, so it's ESX CLI system module. We'll get our help. So let's do list. So these are all the modules that we have access to. And if we scroll slightly back, we'll see that which ones are loaded and are enabled. So most of them are loaded and enabled, all except that guy. So let's see, module list. Let's take a look at parameters list, and it's going to ask for a module, so it's -m and the module name, Sun RPC. No. Oh, I was trying to remember which. Oh, NFS client. That has some options. Has an option. How about that? And that's an option. So the name of the option is one request. It's Boolean, which means you set it as either true or false. And if you set it to true, it only allows one outstanding request at a time, which is going to greatly slow down your NFS access, but if you need to do some troubleshooting. So if you wanted to set that, let's see, it would be set -p. Let's see. It's going to be one request. And the module is NFS client. It's probably not going to like that. Let's see what happens there. Yeah. I'm trying to remember how you set that. Equals true. Hey, look at that. Okay. They don't offer great help on these things. It's like, hey, here's the parameter. What do you do? So, equals true. And now it'll enable that. Since I do use NFS, I'm going to make that false. Well, that's not what I meant. Yeah, be careful. It'll let you put anything you want to right there. So what if I just do blank? There we go. That should set it back to what it was. So, like I said, let me scroll back to my list. Some of these things have, oops, not parameters list, module list. Some of these have a bunch, and some do not. So, parameters list. We're trying to find one that has a bunch. NMP has none. DM has none. Migrate, none. Of course, the other day when I was doing this, there was a ton of them. And that one has 2. But you just kind of walk through. Oh, iSCSI's got a bunch. Yeah. And you can walk through and take a look at these. But like I said, there's no rhyme, reason, or standard. So, I don't expect you to memorize these. Just know how to set one if you get one on the exam. Troubleshooting iSCSI? Not too hard. We saw iSCSI configuration and multipathing in another lesson. Basically, what I want you to do is check your VM kernels. If you're doing MPIO or doing iSCSI the proper way, and by that, you'll see what I do not mean in my lab in a second, but if you're mapping VM kernels to your NICs, make sure the mappings are correct. In my lab here in a minute, I don't have them mapped. I'm just using the management VM kernel. Make sure you can ping the iSCSI target. If you can't ping it, assuming it's not a firewall issue, you should be able to talk to it. If it is a firewall issue, check the firewall between there. Check the iSCSI target. Check zoning masking on the target. Make sure your IQN, your iSCSI initiator address, is enabled for access on this target. That's usually the issue. And confirm if you are using chat, which is an authentication mechanism, that you're putting in the correct username and password. I don't like using chat because it complicates things, but some people do. Just depends. Most people just put iSCSI on a dedicated network and don't worry about it, but if you do, check that. Some commands. We can view some things. Again, it's ESXCLI iSCSI is the tree, network portal, logical portal, session list, adapter target, and adapter capability. So let's take a look at a few things. First, let's look at vCenter. So with vCenter, let's see here. We've got our iSCSI configured. Go to storage adapters. iSCSI's there. Do a properties. Make sure your IQN is enabled for access on your target. Make sure the status is actually enabled here. I mean, you can disable it, and that's where that checkbox is. If you need to change the IQN for some reason, you can right there. Here's where you set your CHAP information, so make sure that is set correctly. Advanced is some of the advanced features that you probably never have to change unless VMware support tells you to. Network configuration is where you do your mappings. I don't have anything mapped because I'm not doing one-to-one like I should be, but I normally use NFS in my lab. But again, if you need to map those, come in here and do that. We talked about that in another lesson. Make sure you got the right IP for your iSCSI target. It happens more often than you think that people put the wrong one in or fat finger it, which I'm popular with doing that. And static discovery, so when I punched in .75, my iSCSI target actually has a couple of IPs, so it pulled a few other things back. You can grab that. It's my Synology box. But check those. You can do settings on these. You can look at the target name, again, CHAP and advanced. But just confirm that that stuff is all correct. One other thing that I'll show you while we're in here that's not directly related to iSCSI, but I want to show that to you. So here's Data Store 4, which is iSCSI. You can unmount these. It's going to check and make sure that there's no VMs that need it or anything like that on the host. But it will then go ahead and unmount, and it'll gray out. There we go. If you ever have an issue where a host isn't seeing VMs or for some reason can't access a data store and you thought it should, sometimes I've seen this if like the iSCSI target goes down and comes back up, but it doesn't remount properly. So it'll say inactive, unmounted. You just right-click it and do mount. Again, it's not an iSCSI thing, but I've seen it with iSCSI more than anything else, so I'll tell you that. Jump back to PuTTY land, so ESXCLI iSCSI. So we can do things like, let's see, logical network portal list. And it's got your VM, your adapters. Mine are the virtual because it's iSCSI software. My VMKs, MAC addresses, you know, true, compliant because they're not really compliant because I'm not doing my mappings. If you want to look at information such as, is the software iSCSI agent iSCSI client enabled, you can do get and it'll say true. You can then do set if you want to enable it or set if you do not. Remember, if you disable it, it will ask you to reboot the host, so just keep that in mind. You can do plugin information. That just lists plugins. Mine says QLogic because I've got a hardware adapter in here. Let's see, sessions. That's if I was looking at one for the exam, that's probably the one I'd look. This shows any active iSCSI sessions, the adapter, the target, all that information and some settings, so it tells you if it's actually doing anything. You can remove sessions, which basically logs you out of them if you need to. You can add a session if you need to force a login. If you want to see the capabilities of an adapter, you do like or first if you want to see the adapters. Again, mine's software. It's the only one I'm actually using, so it shows that. You can set parameters, adapter parameter, and get. And it'll show the adapter name, which is AVM, let's see, HBA35-A. And it shows all the things that you can set, and then you would do the set command. Most of these things, you know, advanced features you'll do on ESXCLI. Anything else I would do through the UI, through the iSCSI setup. That's the only thing there. I don't expect anything too crazy on the exam, but especially know how to do iSCSI configurations, how to check it, do CHAP, things like that. NFS is a little simpler, at least I think. First of all, can you ping it? Can you ping the NFS server? Yes or no? Like a good network guy, I always check if I can ping things. Use ESX CLI to show and add NFS data stores. Make sure NFS server is set for no root squash. So some NFS servers set this by default. And basically what it does is when the vSphere host connects to an NFS export for your data stores, it does it as a root level user. And some NFS servers say that's not allowed because we don't want anybody to have root over the network. And then it'll squash or set root to either have no access or read only, which means you can't write anything to the data store, which makes vSphere an unhappy camper. So make sure that is set correctly. If you don't want anyone to make a change to an NFS data store, mount it read only, and you have that option when you mount it. And I'll show you that in a second. But this is very common for doing things like ISO data stores that you don't want to change, or templates or something like that that you don't want to get updated or accidentally erased. Make sure you mount all NFS data stores the same way. This is common too. If you use the IP to mount it on one host, use the IP on every host. If you use the host name on one host, use the host name. If you use the fully qualified host name, use the fully qualified host name on all of them. Because vSphere does some stuff, and it will actually create an ID out of that name, and if the names are different, the IDs will be different, and it'll see them as different data stores. So be careful with that. ESX CLI, let's see, what is it? Storage NFS. List, it's going to list my data stores. So again, confirm your name is the same across the board, your IPs are the same across the board, all that good stuff. It'll show if hardware acceleration is supported or not. Again, I use Synology NAS here in my lab. They do not have an NFS plugin. So remember that for NFS VAAI support, you have to have a plugin. Do not. It'll show if it's read-only, which is handy. And then you can just do adds and remove. So add a new one, remove a new one. I personally think it's easier to do that via the UI. But when you add one, you add storage, network file system, and then it's going to say, give me the server. This is where you put the IP or host name, the folder that it's done, and here's where you mount it as read-only. So if you do that, you want to make sure that that is correct. Fairly simple. If you do properties on it, nothing really to set. I mean, I was going to show you that there's nothing in here for read-only. So you get that's a install or an add time change. So if you want to mount that read-only, remove it, re-add it. When you re-add it again, make sure you get the same naming scheme, the same data store name, all that good stuff, but mount it read-only. Other than that, NFS is pretty simple. The only downside is you don't get to load balance it, which is kind of a bummer. But other than that, I'm a big fan. Performance, ESX top and vSCSI stats. So we've talked about ESX top before. Here's your major metrics to worry about. Megabytes per second read, megabytes per second write. Kernel latency, so anytime you do an I/O request through the kernel, it adds a little bit of latency because it has to do something. You want to see that at 3 millisecond or less. Device driver latency, this is basically the device, what we're getting back from the actual storage device. You want that under 25 millisecond. I personally want that under 20 millisecond or even less. Queue latencies, then we have what's called guest latency, which is what the guest OS sees. So this is kernel average plus device average. You want it less than 25. Again, I'd like this less than 20. When you start hitting 20, applications start to notice. When you hit 30, they really start to notice, and then things go downhill fast. Storage adapter queue length is AQLEN. The LUN queue depth, it'll show the amount of IOs for that LUN sitting in the queue. Then you can have a queue depth percentage. Resets per second, disk resets per second. You want 1 or less. I'm going to tell you 0 is what you want. Aborts per second, you want 1 or less. I'm going to tell you want 0 for that. And then vSCSI stats is an awesomely cool tool to get I/O characteristics. So let's take a look at those guys. So good old ESX top. To see a lot of this cool stuff, we hit D to go to disk mode. And that'll show your commands per second, reads, your writes, your megabytes written, your device driver and device average latency, your kernel average here under K average, guest average, Q average. You can hit F like we always do to bring up some of these others, write latencies, read latencies, Q stats, anything like that. So let's look at our Q depth, which is going to be pretty boring, I think. And then we need to change the order. So remember, order is O, and I want Q stats, which is D. So I'll move him over. And then we get our device, Q average, it's basically 0 because this stuff isn't very busy. But it's ESX top. So, it is what it is. You can hit U, and this will pull up your devices such as your NFS data stores, my iSCSI data stores, anything local. and show commands per second, reads, writes, any of that. You hit F, and of course you can pull up this very similar stats here and sort by to whatever you want. There's even VAI stats, which I think is pretty slick. But just remember, question mark, switch display. So you got D for disk adapter, V for disk virtual machine, and then U for the disk device. So hit V, and it shows my virtual machines. Commands per second, which again is like IOs per second, reads, writes, megabyte reads, megabytes written, and latency. So these are where I go when I want to have a troubleshoot a performance issue for disk. But again, everything else we learned about ESX top is the same. If you want to record this, do it in batch mode, dump it out to a CSV. Now let's talk about vSCSI stats because it's new and it's cool. So let's say that I'm a consultant. Well, I am a consultant, I guess. But let's say I walk in and we're talking and we're sizing out a new storage array for you. Or you've got a VM that's having performance issues and we're trying to figure out why disk performance is just abysmal. And I say, well, what size I/O is that thing writing? Is it like 4K I/O or 32K I/O or 128K I/O? And you probably have no idea because most people don't. Or I say, well, how much random access is it doing against sequential read or write? You may not have any idea. This is the tool we can use to find that, which is why I'm a big fan of this tool. I do a lot of storage design and work, and it's a great way to get this information. It's not always the simplest tool to use until you learn how to use it, because it's not like ESX top where you get this interactive display. You basically kick it off, let it run for a bit, and then you start pulling stats out of it. So let's show you how to use it. So it's vSCSI stats. Notice the capital S. So if you type it out like this, it's going to say, I don't know what you're talking about. So always type VSC and hit tab for completion because I'm lazy and it's correct. And we need to know what we want to capture, so do -L. So when you do -L, it spits out the name of all the VMs currently running on your system. And the two numbers you need to care about are your world group ID, which is your main number here, and then each virtual disk underneath the VM has its own handle ID. So this guy has one because he only has one virtual disk. This guy has two. He's the UI VM for vCenter Operations Manager. He has two, so he has two. Meaning you can pick and choose exactly which disk you look at. So he doesn't just glob all the stats together. It actually will let you pick out which disks do what. So next thing you need to do is kind of turn it on. So let's see, vSCSI stats, and let's do help so I can walk you through this. -L is where we list the machines. -R resets the stats. -S starts. -X stops. It will also stop after like 30 minutes. So if you run it and walk away for an hour, it will stop after I believe it's 30 minutes. So be careful of that. You set your world. Set your handle -I.NET, not -H. I was using this the other day and could not for the life of me figure out why I couldn't get this thing to start. And I'm standing there going -H, handle ID, and it kept spitting help out at me, and I'm like, oh, wait, that's right. So, heads up. We'll use -P to print out cool information when we want it. And if you want to dump it to a CSV file, you do -C, and then you do like greater than name of file.csv. Else it spits it out to the screen, so you got to capture that. The cool thing about CSV is, like I talked about when we talked about batch mode for ESX top, is we can pull this into Excel and make all sorts of neat charts and graphs. You want to know the latency of this SQL VM, Mr. DBA? Well, here you go. Or you want to know if it's doing sequential I/O? Well, here you go. And you can do some neat stuff. So let's get started. vSCSI stats -L, and we're going to use the UI VM. So vSCSI stats -S to start, -world is 199.0.0.3. I'll just let it go, which should do both of them. And I think that's all I need to do to start. Yep, there it goes. It says it started collecting. So now what we can do is let's pull help back up again. After we let this guy run for a bit, we can do -P. And -P will print out what we want to know. So what we can do is say all, if you want to look at everything, IO length, which says what size IOs are being requested to and from this VM, seek distance, which is basically telling you how much is sequential and how much is random. So it's like how far away are the writes or the IOs from each other. Outstanding IOs, how much it's throwing, latency, how much latency it's seeing. An inner arrival, I'm not entirely sure what inner arrival is because I've never really seen a good answer for that. My thoughts is that it's for like how much mixed I/O it's doing, but I honestly don't know. Let's do IO length. So what we see here is it usually gives you, and the reason I want you to do this is two things. So one is I don't recommend you do all 2 years to the tool because it spits a ton of stuff at you. And two, let me actually do a handle ID. So IO length world ID is 199.0.0.3 and handle ID is 82.15. So let's scroll up. And usually it'll give you 3 things for each one. If I had done both disks, it would have given me 6, but I want to explain this. So this is the IO links for all commands. The next batch is IO links for read commands, and then it's IO links for write commands. So that's why you almost always get 3. So if you do, if it's at random or not, it'll do here's a dump all IOs. If you just want to see the total aggregate, then it'll say here's read and here's write. The way it splits this down, and there's a name for this kind of chart, and it escapes me at this second, but basically it says, okay, how many of these IOs are less than or equal to 512? Then how many are less than or equal to 1024, and it goes down. So what we can tell by this is my write commands, is that 35 of them were less than or equal to 4096. And basically, since the next number down is 4095, they are 4096. So 35 were that. 6 were 8K. Another 6 were 16K, or actually a little less than 16K because we've got 2 spreads there. 2 were 32K. 10 was 48K. And 4 was like, I guess that's 80K, something like that. But it shows it's got a spread. The majority are small IOs, small 4K IOs, which I would expect to see on this application. But you may see, if it's an application saving large image files, it's probably a bunch of large IOs. But for this, it's a bunch of smalls because it's basically just accessing data. And if we look, while we were running that, only 2 of the IOs were actually reads. Scroll. Let's see. There's my mouse cursor. Let's see. Yeah, 2 were reads. All these were writes. And here's the aggregate, which should be the total of the 2, which it is, because that went from 35 to 37. So let's see how much of it is random data. So instead of IO length, we want seek distance. And basically what this is telling you, it'll tell you up here LBNs, distance and LBNs, which are logical block numbers between each command. So the more that are 0 or close to it means they're sequential. The more that are up here means it's more random. So one common thing I like to do is pull this into Excel and create a bar chart for these numbers. And like you will see charts like with peaks on one end and the other end, which means it's very random. Or you see them with like a curve where it peaks up in the middle and then it's down on both ends, which means it's very sequential read and write data. So basically for this, since, let's see, 41 of them are within one logical block number, that's all sequential. And then we start to spread from there. So it's sequential with a good mix of random. So it's a good way to pull that information. And this is why I like this tool. It's a very simple tool once you understand the interface and figure out how it works and what you want to see. So let's do one more because I like this thing. Let's do, what's my latency numbers? Let's see. Oh, this is in microseconds, so divide by 1,000 to get milliseconds. And let's look at the overall. So overall, we were within 5 milliseconds. Sometimes we're within 1. That's pretty darn good for, I mean, I understand, my VMs aren't really hitting the storage heavy, but that's a, a Synology box with 5 SATA drives in it. It's 7,200 RPM SATA, so I'm getting really good latency numbers here. So it's a quick way to see what your spread on latency is. So, and do -X and it stops all. So it's a great tool. Big fan of vSCSI stats. How would you get tested on this? Well, I could see them say, show me for this VM such and such. Show me, print out a CSV file of the latency. So we do vSCSI. Told you I do dashes or tabs to autocomplete. So we would, turn it on again, which is the -S in the world. Let it run for a few minutes while you do another lab, the next lab or something, and then come back and say, okay, I want to print, let's say it wants to know how much of the data is random. So we do printout seek distance, -C for saving it to CSV file, and then it'd probably give you a place to say it, so I'm going to say temp output.csv, ls/temp, and that didn't work. Oh, I forgot my greater than sign. Told you you need the greater than sign. Wham. Let's see. Temp cat temp output CSV, and it dumps it into CSV. So you can pull that into Excel and give you a nice little chart and graph. So that's about the question I would think they would ask you, and that'd be how you do it, and just make sure you save it in the right place. And the next one is become familiar with VMKFS tools. This is spelled out, this tool, a few times within the blueprint. So I have a little trouble figuring out what they test you on this that you couldn't do through the standard UI, but they want you to be familiar, so I'm going to tell it to you. It's basically a tool that lets you manage VMFS volumes. You can extend them, create them, format them, upgrade them, all that using this command. So it's pretty handy if you need to do it from a CLI. Creating a file system, VMKFS tools, -C for create. VMFS5 is the version. -B is your block size, which as we all just learned, VMFS5 is always 1 meg. -S is the data store name. And then the /VMFS/devices/disk/device ID : partition. You have to partition your volume. And that's the annoying thing about using this tool to create file systems, because you have to partition the disk. And you used to use fdisk, which was fairly simple. Now you use a tool called partedUtil, partedUtil. I'm not sure how you're actually supposed to pronounce that. Problem is, you have to go in, list out the number of sectors and clusters and all this stuff on the disk, and then manually set up the partition. If you format a volume through the UI, it does all that for you. So that's what I do. You can upgrade, so VMKFS tools -T and the data store UUID, or extending one, basically giving a partition on one device and then extending it with the next. So let's see, VMKFS tools, and the one I'm going to do is upgrade. So before I do that, let's go to vCenter, because I want you to know how to do this both ways. I have a VMFS version 3 data store. To do an upgrade from 3 to 5 in the UI, you just click upgrade to VMFS 3, or upgrade to VMFS 5, and it's going to say all hosts must support VMFS 5, version 5 or newer, and it confirms that, and you're allowed to say OK. That's the way I'd do it. But if you're like, man, I'm going to command line, I don't care what Jason says. So we'll just do it using VMKFS tools, -T, capital T, /VMFS/volumes, and then you can just do VMFS 3. And it's going to say, look, it's funny that it gives you a scarier warning here than it gives you in the UI, right? Please ensure that the VMFS 3 volume, blah, 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 set is not an active use by local or remote 3 or 4 servers, which means make sure that's only version 5 that's using it. We recommend you back up your data, and again, confirm no other older ESX hosts are using it. So do you want to continue? Well, yes, I do. Checking remote hosts are using this device's valid file system, and it's going to go through this process, and then it's done. So if we go back to vCenter, do a refresh, VMFS, it should see it as, that's funny, it doesn't. Oh, there it goes, refresh. Now it sees it, and that's gone. So that's how you do it from the CLI. Like I said, you can do all kind of other cool stuff with this thing. You can do fix. It'll check the integrity of a volume. So it'll say -X. You should check repair. Oh. If you check it, it lists errors. If you repair it, it'll actually perform repairs. It's kind of like the old check disk. Oh, it's not a oh, I'm sorry. You have to do that on a VMDK. That's not a volume command. Let's do data store 01. See if I can get it to do it on something. XP2, something I don't care about. VMDK, XP, vnic, -flat. It's not a virtual disk. What do you want? What do you want? What do you want? Oh, you're right. Error-free. Well, that was exciting, wasn't it? So just make sure you're doing the right one, not the flat file like I try to do. But that's real exciting. But if it found an error, you can use this to fix it. Let's see, we can extend disks. You can use this to migrate virtual disks. If you want to migrate them, do basically a storage vMotion from the command line. You can create RDMs, you can query an RDM, create an RDM pass-through, get your geometry of your disk. Is the chain consistent? Clone virtual disks, rename virtual disks, delete virtual disks. You can create a disk using eager zero thick, or inflate a thin disk, or write out the zeros. So there's a lot of stuff you can do here. A few things like checking, renaming is easier here. Migrating. Some things you can't do the UI. I mean, you can migrate, but really anything else, I think you're fine. Let's see. If you want to inflate a disk, it's almost easier just to storage vMotion it and have it inflate it while it does it. Things like that. But it's a good tool to use. Know how to do it in case you need to do some stuff via the command line. Snapshot, resignature. We talked about this earlier. So if you try to mount a LUN to the host and it's seen as a duplicate data store, it'll give you some options. And just remember, it does this because each VMFS volume has a unique ID, UUID. So it's going to recognize that. In most cases, the reason for this is it's a clone of a LUN or a snapshot of a LUN, and we often see this in DR. So I wanted to show you this. I didn't show you this the first time, but I'm going to show it to you now. Let's see, go to storage, go to add storage. It's a disk or LUN, and it should pop up a few things I have presented. I basically cloned one of my LUNs. I can do that on my lab boxes. So hopefully it'll pop that up. There we go. We'll choose LUN number 1 next. And it says, who? I've seen this before. What do you want me to do about this thing? And basically you can keep the existing signature and it'll mount it without changing the signature. We can assign a new signature, and basically it'll say, look, if you have references to the existing signature from virtual machines, you'll need to update those. Or we can just say, format it, which just blows it away. It resignatures it and you lose all data. Most of the time, if you're bringing in a snapshot, you may want to resignature it so there's no confusion about which volume it is. The only other time is if something happened to the original, and this is like a clone that you want to use, then you would just keep the existing. But if the existing is fine and you're bringing this in as a snap, I would resignature it. But I wanted to show you that UI just in case you hit that. And that's it for this lesson. So again, the things I would know how to do. What? Know your ESX top stuff. Know how to do your vSCSI stats stuff. Know how to troubleshoot NFS and iSCSI. Make sure you know how to configure those, but also troubleshoot them. Know where to look in log files in case they throw some weird troubleshooting question at you. Know how to resignature a LUN like I just showed you. And I guess that's really about it. Know how to upgrade VMFS 3 to 5. I can see that as an easy test question to do. Throw you a VMFS 3 and tell you just to go upgrade it. Nice thing is, on simple questions like that, you're like, yes, I got some points, and I didn't even have to think about it. So just know how to do that. But other than that, I mean, fairly straightforward. Just know your tools and commands. And that's it for this one. Look forward to seeing you on the next lesson.